Hey, welcome back to the bench. Good to see you again. Thanks for joining the channel. Today on the bench I have a Kenwood GE-9X graphic equalizer. Now I have mixed feelings about graphic equalizers. I kind of question their existence, why they exist, but they do have a purpose. I did used to own a graphic equalizer back in the day. I had a Kenwood. It was a 32 band. It had 16 on each channel, and it was a big massive unit. Stood about 7-8 inches tall, and I don't know, about 10 inches back. It was just a big empty box, because all they are is really a bunch of potentiometers, some op amps inside, and some switching, and a little power supply to power it. It doesn't take much power. There's really not much there going on inside. But I don't have that today, but I do have this one, and this was brought in from a client for service, so we're going to take a look at it and see what we can do. So let's look at the features of this thing. We have a power button, LED below it, and we have a record LED and a reverse LED and a normal reverse switch. Now I think what they're doing here with this normal reverse is they're swapping the channels left and right. I think that's what that is about. I'm not quite sure. And then they have a -6 dB attenuation, as a kind of like attenuate the signal as it goes through the equalizer. If you find it's too loud, let's say you have all these bumped up to max, this is typically how people use equalizers. They go like that, and then they find, oh, the bass is too loud, so let's attenuate it a bit. So I don't know, I'm just guessing here. You have 10 sliders for each channel, and frequencies are 1632 hertz, 64, 125, 250, 500, 1, 2, 4, 8, and 12, 16, 20 kilohertz. Now notice they kind of double in frequency as they go up the spectrum. There's there's a bigger spread up here than there is down here. So you got more control over your lower frequencies. And the reason they have 1632 and 12, 16, 20 kilohertz on this side, I'll explain that in a bit. So we have lots of control over our tonal quality, and if these are working good and they're not scratchy, everything's fine. Here's the other channel. We have 10 sliders on this side as well, same thing. Now we have a defeat button on the equalizer, which is kind of odd. Doesn't feel like that switch is latching, but I don't know why they would put a defeat button on an equalizer. If you want to defeat the equalizer, just take it out of the tape loop. It's kind of weird. Record button. I'm not quite sure what this does, but it does have input selector, so we can select from line, tape A or tape B. Okay, so this is like a tape monitor, and it does have 2 tape loops on the back, so you're able to connect 2 tape machines to this equalizer and run them through one tape monitor on your receiver or amplifier. So it's good that way. You can stack up your tape decks. Record selector, you can also select your source from recording, either source from your receiver, or you can record from tape A to tape B, or tape B to tape A. Now here's these frequency splitter buttons. There's a switch here for 16 hertz or 32 hertz. And what that does is when it's in 16 hertz, this slider is attenuating or boosting 16 hertz. When you switch it to 32, it boosts or attenuates 32 hertz. So it's kind of like a sub filter, gives you more boost lower in the range, so you get better bass if you so choose. And then they have the same thing on the high end. They have the switch for 12 kilohertz, 16 kilohertz, or 20 kilohertz, and that's for this slider here. So when it's up like that, you can boost 12, 16, or 20 kilohertz. Now that's another personal preference thing that you can fool around with and listen to. Okay, on the back we got 8 connectors, or 6 connectors, sorry. Line in and out. This line goes back to your receiver through the tape monitor loop or other accessory loop that you might have. So anytime the tape monitor's on your receiver amplifier is engaged, you'll be coming through the equalizer. You also have two tape loops, tape A and tape B, record and play functions here. So you can add two tape decks in addition to whatever tape decks your receiver or amplifier can handle. Not much else, has a courtesy outlet, and that's about it. Alright, screws are out. Here's our first look. And there it is. Now this looks like it has a lot more than I normally see inside an equalizer. Usually it's just a big empty box, and then you have all your tone controls up here. And this here, I don't know what this part is. This has a relay. I can see a relay. And this part here looks like power supply. And then we have our input switching. There's some switching on this level, and there's probably switching on the level below it. And then there's probably another board underneath that we can't see. So there's lots of switching going on, because they are running two more tape loops through this. So you can see all the tracks and lines for that. Don't know if this works or not. I'm assuming it does. Usually there's really nothing that goes wrong with these things other than dirty pots and maybe power supply burnout. So let's power it up. Let's get a receiver or amplifier that has a tape monitor on it, and we can use that as our test bed. So happens this has a removable bottom, so it makes access a lot easier, and that really opens it up. So you can see right here we have our power supply. And this is the tone shaping board. It's separate from the potentiometer board. And this is our switching for, this is our tape monitor switching here on this board. And then, yeah, that's pretty much it. Not much going on here. Alright, so I've enlisted the help of this HK350i. This is a receiver that's sitting and waiting for the bench for repair. I don't even know what's wrong with it, so we're going to test this out while I'm testing out this. So let's turn this on, and let's see what we get out of this thing.
Isn't that your next chance to play? Come another one.
Okay, it is working. Let's engage the tape monitor. Let's turn this on. Relay click. Let's see here, line. Let's go for a line. Tape A, tape B. Okay, equalizer's on. Minus 6 dB attenuation. It went down in volume. Normal reverse. Okay, so this is working. Let's try auxiliary. I got a tone going. I have a 20 hertz tone. And this looks like the right channel might be having some troubles. Let's turn this tone up a bit. It's 100 hertz. Let's go to 64 hertz. Okay. It's having some troubles. The right channel's having troubles. Yeah, this receiver is having troubles on the right channel. Okay, tape monitor. Now it's working. I don't know if you can hear that. try 32 hertz. I don't think this camera is going to pick up 32 hertz. Let's see here. We have that switched to 32, yeah. It's working. Let's try 125. This right channel does not. Hearing a lot of distortion out of the right channel. Just ignore that for now. Let's just get through this. Where are we here? We are on auxiliary. Balance. Okay. I'm doing the wrong slider. There it is. Yeah, some of these are dirty. Getting a lot of dirty. Okay, let's try 250. I got left. Right. This HK needs a good service. Okay, 500 hertz. So not the ideal receiver to be doing testing with, because this thing has multiple issues on its own. So I'm just kind of trying to get through this here. Let's try left channel. Left channel. That buzzing is not. Getting lots of strange harmonics and noises. Okay, let's do everybody's favorite 1 kilohertz. Left. Yeah, these guys are just going to need pot cleaning. Right. It's pretty weak on the right. Left. Okay, it is working. 2 kilohertz. Yeah, pretty scratchy. Yeah, so I'm going to need to service these sliders. I think the switches are okay. Don't see any issues with the switches. So far it's just trim pots. Okay, 4 kilohertz. Let's do left first. Pretty poor. Let's try the right channel. Okay, I think I got a good idea what's going on here. To treat all these trim pots, or these sliders. And that's pretty much it. Other than that, this thing needs work. Let's see here. Let's shut this off. This HK receiver is drawing 46 watts. It's a little high. It's really high. It's probably, yeah, it's starting to get warm. It is probably in need of a good service. So, let me get started. What I'm going to do is I'm going to remove probably all these. Can these pull off? I don't know. Yeah, they have LEDs in them. Pull off all those, and I am going to start by treating all these potentiometers. I'm pretty sure that's the only thing this needs other than cleaning, and I can also treat the other switches as well, but that'll be it for this. Okay, I got the front panel off, front cover. Now I can see into the potentiometers. They have, I can't really show you, but I can see it myself. There's a divider down the center inside, and then there is a silver track and then a resistive carbon track. And then same on this side, there's a silver track and then a resistive carbon track. So my plan is I'm just going to do some deoxit FL100 or F100L, and I'm going to put a little dab on each of those tracks, and I'm just going to work the potentiometer, and we're going to see how that comes out in the end here. I have a feeling that's all it really needs. Doesn't really look dirty in there. I don't see a lot of oxidation on majority of these. On one or two I see a little bit of oxidation, but it's not bad. And the other thing is I just want to check and make sure all of the solder joints are good and there's no cracks, because we had some channels cutting out when I was playing with some of these sliders. They were cutting out, so I don't know. I don't think there's any problem with that, but let me get started with this. Okay, I'm looking at these potentiometers, and I don't know if you can see inside there. You probably can't see inside. Let me see if on this one maybe if I get the right. You can probably see a track right there. There's a silver track. If you go look on one of these other ones, you'll probably see a silver track on that side. Now those two silver tracks I think are just supplying power for the LED, and the other tracks that do the resistance attenuation or whatever adjustment, I think they're deeper down. So I did treat all of these pots, and I'm not sure if my treatment got it down inside. So what I'm going to do is I'm going to disassemble this, take this board out. Now I did see some cracks on the back side here on some of these potentiometers, so yes, there was cracks solders, so I'm going to take it apart and resolder it. But I want to take one of these potentiometers apart just to look inside and make sure the treatment I put in is getting to the right spot. That's what I want to do. Alright, here's one slider I took out to test. Just want to open it up and see what's going on inside. Now, I don't know if you notice there's a number 1 marked here, right on this end by that screw hole. This end has no markings. If you flip it over, you notice that this terminal here is marked number 1. So that goes with that. And then this one's marked number 2. And this one down here is marked number 3 and number 4. And then we have what looks like a B on this one and an E on this one. So we have to remember that so we don't mix it up when we put it back together. So let's just open this thing up and see if my treatment got to the right spots. Let's see how this thing's constructed too. I don't think I've ever opened up a slider before on this channel. Might be a first. I don't know. I'm sure some of you other people will know if I did or not. I certainly can't remember. All right. So let's peel this off careful. And yeah, it looks like we have we have this set of contacts and this set of contacts are connected together. This set of contacts and this set of contacts are connected together. So and then here we have what looks like a resistive track on this side and a resistive track on this side, and then down the center we have our 2 silver. And yeah, like I said, this probably supplies power for the LED. If I pull this out, there's a ball bearing there under a spring. Gotta be careful of that. And this LED is connected directly to these 2 here. These are independent. Okay, so that's how it works. So let's put this back together. You want that ball bearing pressed in. And there it's in. So I think, let's see here. Let's clean off this track. Let's clean off this track. See all the dirt that accumulates on that one. So it looks like my treatment is working here. This part looks dry. Put a little bit there. So I think it's going to work. Let's put this back together. Where's my number 1? Up top on my thumb. Number 1 is over here. Okay. Let's put this back together. Okay. I'm happy with that. Let's put this back together and close it up, put it back in. This here, I'll squish this. Okay, so I'll crimp this down and then we're done. One thing I wanted to get away from is disassembling all 20 pots and cleaning each one of them. It's not something I want to do, spend my afternoon doing. So I think just the treatment of the Deoxit F100 will be good. We'll test it out and see how it sounds after. Okay, that's ready to go back in. It's good. Now, see where I took the pot out from? I just picked a random one. So yes, some of these joints here are cracked. And I didn't look at this one. This board's okay. Well, no, I'm going to resolder them all. I'm just going to redo it because, yeah, they're cracking. And it's probably causing problems. So you know me, I started poking around the power supply and I started seeing dead caps. So might as well just change them all. This is, there's not very many here. It's just a small few. It's just this little bit of heat here from these transistors. Cooked this one, cooked a few more. So I'll just replace them all and then be done with it. Well, there it is. I got it back together. Cleaned it up a little bit. I just want to show this here. Drawing 10 watts. Oh, just ignore this. That'll clean up. Yeah, 10 watts. That's when it's powered on. It actually has no power switch on the AC mains. This transformer is always live, and the secondary is switched here with this blue wire and this brown wire, which is not a big deal. It draws approximately 1.2 watts when it's sitting idle, or turned off I should say, and then when you turn it on it's 10 watts. So there is a differentiation of that. Now, I was surprised these caps were bad, and by bad I mean they're pretty bad. Like I have some of these here. Here's a 22 microfarad at 25 volts, and we should have, let's see here, we should have an ESR of about 2 ohms, let's say. Okay, so let's check this one, and I'm just going to hook it up to my tester here and get a reading on this. Now, let's see here. I'm getting 9.5 microfarads instead of 22, and 18 ohms ESR instead of 2 ohms, so that capacitor is pretty much cooked and shot. And a lot of the other ones were the same, except for the large ones. They were weak. They had high ESR and they were getting down in value, but these ones are the worst. Just that they have a little regulating power supply here. It takes, the transformer provides about 26 volts I measured, positive and minus, and then it regulates it down to plus and minus 15. And that little voltage, there's a little transistor there that does the regulating. That gets hot and creates heat, and everything's mounted upside down, so the heat has to flow up. It hits the board and it flows out. But if I put my hand under here, I can just start to feel it getting warm. I don't feel any hot spots, so it's all good, I think. Gonna end this here. I'm done with it. I treated all the potentiometers. I went back here and soldered up all of these potentiometers. Some of them were cracked. Checked over all the other boards, soldered up what I could see as questionable, cleaned everything. Didn't do anything with the switches. They all sounded fine when I first tested them. And I'm going to continue testing this. I'm going to put this in my system and use it for a few weeks. I don't use equalizers. When I listen to music, I listen to it with the tone control flat or cut out. So I don't really, have any use for bass or treble controls, but an equalizer is even more redundant to me. But I'm going to hook it up, try it out, and see how it goes. And I'm not going to bore you with the details of testing this. So, all right. So that's it for this one. Take care, and we'll see you on the next one. Hope you're all well.